Howdy, let's return back to the Suppes and Hill textbook to section 2.3, Sentential Derivation. This video is largely a review and reiteration of the previous material, thus we will focus on basic exercises. And these are largely basic. They are to get us comfortable with propositional logic. But before we get into them, let's set the stage a little bit. Remember that the rules of inference allow us to move from one set of sentences to another set of sentences, where the formal derivation is the method by which we prove an argument valid. And an argument is a set of premises and a conclusion derived from the premises. Remember, the premises are a given set of sentences we take for granted. We then, in an argument via a formal derivation, attempt to derive a specific sentence, which we call the conclusion. An argument is valid if the conclusion follows from the premises. Now, the textbook compares logic to a game. A proof is a game. The rules of the game are the rules of inference. Each step we make in the game must be allowed by the rules. The goal is to derive a particular conclusion, and that is what we will be doing in these exercises in the following slides. Flipping to page 73 of the Suppes and Hill textbook, we find part A of exercise 9. In each of the following examples, prove that the conclusion follows from the premises given. Argument number 1 states that if this is a matrilineal society, then the mother's brother is the head of the family. If the mother's brother is the head of the family, then the father does not impose discipline. This is a matrilineal society, therefore the father does not impose discipline. The first premise, we have a conditional. This is a matrilineal society, we can give M. The mother's brother is the head of the family, we can give an H. So for line 1, which is just a premise, we have if M, then H. If the mother's brother is the head of the family, then the father does not impose discipline. We can give that a not F, taking into account that negation. So that just represents the father does not impose discipline. So for line 2, which is a premise, we have if H, then not F. This is a matrilineal society. Hence line 3 is just M. And these are our premises. And our conclusion is, therefore, the father does not impose discipline. So therefore not F. Premise 3, M is the case, we're told. Premise 1, we have a conditional. We could affirm the antecedent because we know M in fact is the case, and so we could affirm the consequent H. Hence for line 4, we can get H by modus ponens with lines 1 and 3. We know H is the case. We could affirm the antecedent, and that's sufficient to say not F is the case. So we reached our conclusion on line 5, therefore not F by modus ponens with lines 2 and 4. Argument number 2 deals with geology, which is a subject I know pretty much nothing about. Although I did take a professor who was, strictly speaking, a geologist. He taught geology, but I didn't take him for that particular class, and at the time I just thought, boy, geology must be one of the most boring subjects in science there is, because, hey, just about rocks. But it turns out it actually is an interesting subject, but it's just one of those subjects that I know nothing about. Or at least almost nothing about. Let's look at the argument. So we have a disjunction first. Either this rock is an igneous rock, we'll give that an I, or it is a sedimentary rock, we'll give that an S. This rock is granite, we'll give that a G. If this rock is granite, then it is not a sedimentary rock, therefore this rock is an igneous rock. So we have our first premise, which is our disjunction, I or S. Our second premise, we just have G, the atomic sentence. And our third premise, we have if G, then not S. And from these premises, we should get the conclusion that I is the case. The first thing to notice is that second premise states categorically that G is the case, so we could affirm the antecedent to the conditional on line 3 to get not S. So for line 4, we get not S by modus ponens with lines 2 and 3. Notice the disjunction, line 1, I or S. The Suppes and Hill textbook would allow us to get I with the disjunctive syllogism. Some textbooks would require us to do the commutative law first, so I'm going to do that for the heck of it. For line 5, I'll say S or I, commutative law, with line 1. And now we have S or I. We know S is not the case, so for 6, we can get I by our disjunctive syllogism with lines 4 and 5, also known as modus tollendo ponens. Argument number 3. If Jack is taller than Bob, then Mary is shorter than Jean. We symbolize this as if J, then M. Mary is not shorter than Jean, not M. If Jack and Bill are the same heights, then Jack is taller than Bob. In other words, we have if S, then J. And our conclusion is, therefore, Jack and Bob are not the same height. In other words, therefore, not S. So here we have our premises. We know that M is not the case. This can deny the consequent of a conditional, so we can deny the antecedent. Hence, for line 4, we can get not J by modus tollens with lines 1 and 2. We have not J. That denies this consequent of a conditional, so we can thereby deny the antecedent. Hence, we have not S by modus tollens 3, 4. Argument number 4. If A did win the race, then either B was second or C was second. For line 1, which is the premise, we have if A, then B or C. The Suppes and Hill textbook allows us to drop those parentheses. Other textbooks require those parentheses. If B was second, then A did not win the race. So for line 2, we have if B, then not A. If D was second, then C was not second. So for line 3, we have if D, then not C. A did win the race. So for our fourth premise, we have A, and the conclusion we can get from that is D was not second, so not D. We know A is the case. We also see A appearing in the consequent of a conditional, but it's being denied. So why not double negate A to then deny the consequent of a conditional to thereby deny its antecedent? So for line 5, we can get not A by the double negation of 4. And then for 6, we can get not B by modus tollens with lines 2 and 5. But also note that A appears as the antecedent to the conditional on line 1, so we can get B or C. So for 7, we can get B or C by modus ponens with lines 1 and 4. Line 6 tells us B is not the case, so we can deny B to get C in our disjunctive syllogism. So for 8, we have C by the disjunctive syllogism, lines 6 and 7. C appears negated in the consequent of a conditional on line 3. So to deny not C, we need not C. Thus for 9, we can get not C, double negation 8. And then for 10, we can get our not D, then by the modus tollens inference with lines 3 and 9. Because line 9, we can deny the not C on line 3 to deny the D. Argument number 5. If the clock is fast, then Jones arrived before 10 p.m. and he did see Smith's car leave. If Smith is telling the truth, then Jones did not see Smith's car leave. Either Smith is telling the truth or he was in the building at the time of the crime. The clock is fast, therefore Smith was in the building at the time of the crime. Pretty cool argument. For our first premise, we have a conditional and the consequent has a conjunction. If the clock is fast, then Jones arrived before 10 p.m. and he did see Smith's car leave. So we have if F, then J and S. Second premise, we have another conditional. If Smith is telling the truth, then Jones did not see Smith's car leave. So we have if T, then not S. For our third premise, we have a disjunction. Either Smith is telling the truth or he was in the building at the time of the crime. So T or B. Next we have a atomic sentence. The clock is fast. So for line 4, premise 4, we have F, and our conclusion is, therefore, Smith was in the building at the time of the crime. So from that we get B. So here are our premises, and from them we want to derive B. But we do have F is the case, and that appears in the antecedent to a conditional. So for line 5, we can get J and S by modus ponens with lines 1 and 4. Notice that we have S here, and that's contradictive to not S in the consequent to a conditional. So we're going to want to eventually do a modus tollens inference, but before that, for line 6, we can get S and J by the commutative rule with line 5, and then we can simplify to get S, but simplification of line 6. We want to explicitly state that we can deny not S, so we need not S. Hence for line 8, we can get not S, double negation line 7. And now we're in a position to deny this consequent, to deny the antecedent. For line 9, we can get not T, modus tollens, 2, 8. And finally, notice that we have this not T. Line 3, we have this disjunction T or B. T is not the case, so B must be. Hence for 10, we get B by our disjunctive syllogism, also known as modus tollens ponens, with lines 3 and 9. Here's a good representative sample from part B of exercise 9. We have number 6, number 9, number 11. With number 6, we want to prove the conjunction S and T. We're given 3 premises. Premise 1, if P then S. Premise 2, if P then T. Premise 3, P. Well, P is declared to be the case. This means we can do some modus ponens inferences, because we could affirm this antecedent to get S. We could affirm this antecedent to get T. Thus, for line 4, we can say S by the modus ponens inference with lines 1 and 3. And then for line 5, we can get T by the modus ponens inference with lines 2 and 3. We want to prove the conjunction S and T. S appears on line 4, T appears on line 5. Just combine them together. Hence for 6, we can get S and T by the conjunction rule with lines 4 and 5. The conjunction rule is also known as the adjunction rule. So that proves that. For number 9, we want to prove not T. We're given 4 premises. The first thing to ask, is anything categorically stated? And yeah, sure. Line 2, we have P and Q. We have a conjunction, but notice that P appears in the antecedent to a conditional, so why not simplify and then do a modus ponens inference? Thus, for line 5, we can get P by the simplification of line 2. And then, for line 6, we can get S by modus ponens, lines 1 and 5. Notice as well that we have a Q in our conjunction, and Q appears as an antecedent to a conditional. The Suppes and Hill textbook would allow us to simplify right away to get Q. Other textbooks, you can only simplify with the first term, so we have to do the commutative rule first. So for line 7, we can get Q and P by the commutative rule on line 2, and then for line 8, we can get Q by the simplification from line 7. And now we can do a modus ponens inference to get R. Because Q is the case, R will be the case. So for 9, we can get R by modus ponens with lines 4 and 8. On line 6, we have S. On line 9 we have R. Notice that line 3 we have S and R, this conjunction as the antecedent. We can now affirm that as long as we combine lines 6 and 9 through the conjunction rule. So for 10, we can get S and R by the conjunction rule with lines 6 and 9. And now we can do the modus ponens inference to get this not T, because S and R is sufficient for not T being the case. So 11, not T, by modus ponens with lines 3 and 10. For 11, we want to prove S. We're given 4 premises. Let's see, we're given P. P is the case, and P appears as the antecedent to a conditional, so let's do modus ponens. For line 5, we can get Q and R by modus ponens with lines 1 and 2. By the way, this time I use the ampersand. That's another symbol for and. The other symbol is the wedge. It's the wedge, the ampersand, both of those can represent the expression and for the and sentential connective. But anyways, we do have Q and R, and note that to a conditional, we have this not Q in the consequent. Q appears here, so why not simplify and then double negate? Because then we can do a modus tollens inference. So for line 6, we can get Q by the simplification of line 5. We have this not Q. To deny that, we need not Q. So for line 7, we'll get not Q by the double negation of line 6. And then, because we can deny this consequent, we can deny this antecedent. So for 8, we can get not T by modus tollens with lines 3 and 7. Notice line 4, we have a disjunction, T or S, but T is not the case, so S must be the case. Thus for 9, we can get S by our disjunctive syllogism with lines 4 and 8. Not bad. Part C, I suppose, is a bit unusual. Still, the atomic sentences are just straightforward mathematical statements. Though they might look strange or a bit difficult, they really have the same formal status as the previous problems, so they're not too bad. Also notice the negation signs. As I'm sure you are aware, this sign right here means not equal to, but also check out this sign. This means is not less than. For part C, I'm going to do 2 problems here, number 4 and number 8. Number 8 is a bit tricky to be sure, but let's start at number 4. We want to prove that y is greater than z, and we're given 4 premises. The first thing I like to do is to ask myself, is there any premise that declares categorically something to be the case? For example, is there an atomic sentence there, or is there a conjunction? And obviously we do have a conjunction, line 4, premise 4. So we have this and statement. We're told that y does not equal z, and that x does not equal z. Then the question is, does one of those expressions appear elsewhere? And yeah, sure. Line 1, we have a conditional. The consequent, we have x is equal to z, and that contradicts x does not equal z. So eventually we should be able to do some kind of modus tollens inference. For line 5 then, I'll say that x does not equal z, and y does not equal z. This is the commutative rule, line 4. And then for 6, we can say x does not equal z by the simplification of 5. And x does not equal z denies this consequent, so we can thereby deny the antecedent. Hence for 7, we can say x does not equal y by modus tollens with lines 1 and 6. Also, because we know that x does not equal y, according to line 7, and that appears as the antecedent to a conditional, we can do a modus ponens inference. So for line 8, we'll say x is less than z by modus ponens, lines 2 and 7. Line 3 is a disjunction. We have this or sentential connective. X is not less than z, or y is greater than z. We have this statement that contradicts one of those choices in the disjunction, so eventually we should be able to do a disjunctive syllogism. But for now, let's double negate to explicitly show everything line by line. Thus for 9, we can say it is not the case, parentheses x is not less than z by double negation of 8. And now we are saying that can't be the case. We know that's not the case, so it must be that y is greater than c. And we can conclude this argument, this proof. Disjunctive syllogism, lines 3 and 9. For number 8, we want to prove that x is greater than 6, and we're given 5 premises. We have a conjunction there, line 4. We have this x is equal to 3 plus 4. That appears as the antecedent to a conditional. So why not for line 6? First simplify, we'll get x is equal to 3 plus 4. Simplification, line 4. And then we can do a modus ponens inference to affirm that consequent. So for 7, x does not equal 5. Modus ponens, lines 5 and 6. Now what should we do? Well, look at line 3. We have a conditional. The consequent, we have x does not equal 3 plus 4. And that contradicts this statement here. So the consequent and this statement contradict each other, so we should be able to do a modus tollens inference eventually. For 8, let's double negate. So we'll say it's not the case that parentheses x does not equal 3 plus 4. Double negation, line 6. And then we can do our modus tollens to say that x is not less than 5. Lines 3 and 8. Line 2, the antecedent to a conditional, we have x does not equal 5 and x is not less than 5. Well, we have that. Line 7, line 9, let's do the conjunction rule. So for 10, we can say that x does not equal 5 and x is not less than 5. The conjunction of 7 and 9. And then for line 11, we can get x is greater than 5. Modus ponens to 10. And since we now know that x is greater than 5, we could affirm this antecedent. Hence for 12, we can get x is equal to 6, or x is greater than 6 by modus ponens with lines 1 and 11. On line 4, we have a conjunction. We're told that x does not equal 6, so that contradicts this. So for now, let's say for line 13 that x does not equal 6 and x is equal to 3 plus 4. Commutative rule, line 4. And then for 14, we can say x does not equal 6 by the simplification of 13. And now because we have this x does not equal 6, so that's not the case, and there must be one true statement in disjunction. For 15, we're able to conclude that x is greater than 6 by our disjunctive syllogism with lines 12 and 14. To become proficient in logic requires practice. Nevertheless, I hope these videos are somewhat helpful, somewhat useful. And up next will be section 2.4, more about parentheses. I'm the amateur logician.